Imagine you had a heart attack 5 years ago and went through an open heart surgery. The doctors used a synthetic vessel graft to bypass the blockage in your coronary artery, and your life was saved. Now here again at the hospital, waiting to repeat the surgery because your synthetic graft is not blocking as well. Why does this keep on happening to me, you might ask? Let me tell you why and how my research will help you. Ideally, for coronary artery bypass grafts, we prefer to use the patient's own blood vessels. But if a suitable native vessel is absent due to age or pre-existing medical conditions, synthetic materials are deployed. Unfortunately, this technology hasn't been improved in the last 50 years, and they all fail within the next 3 to 5 years after surgery. There are two causes of these failures. One is the bad choice of material, shown on the left-hand side. The synthetic materials currently available are what we use in rain jackets and drink bottles. Not only that they're plastic and they don't belong in the body, they also don't have the elasticity that our native vessel has. So in my thesis, I've utilized silk as a biomaterial and woven it into tubes so that they can be used as artificial blood vessels. My results have demonstrated that silk is a much better choice of material, not only because it's a natural protein polymer, it also has a strength and elasticity that matches the native vessel. The other reason why synthetic grafts fail is due to blood clot formation, where platelets aggregate on the synthetic grafts. So how do we prevent that? We looked into our native vessels for inspiration. So in our native vessels, the blood contacting surface is a layer of endothelial cells. And they're like little soldiers that whenever a platelet comes into contact, the soldiers will fight them off, make them go away, so that they can't form blood clots. So if we want extra soldiers to come into the battlefield, we could lure them with burgers. But what can we use to attract endothelial cells so that they'll come onto our graft? In my lab, we have bioengineered a molecule that's called recombinant protein domain 5, and I was able to demonstrate that this molecule can not only make endothelial cells stay, but also recruit more and train them so that they're ready for battle. So together, I have this novel bioengineered vessel graft that has silk as a scaffold, providing the mechanical strength, and the recombinant protein domain 5 as a biological cue to encourage regeneration. Hopefully one day in the future, instead of going through open heart surgeries every few years, this novel graft can provide long-term benefits for patients with cardiovascular diseases. Thank you.